Alright, in this video we're going to take a look at simplifying square roots and radicals as well as cube roots and those radicals that have variables in them. We should have watched our video from previously about simplifying radicals, so this is taking it up a notch, taking it to the next level. There's a couple of things that we've already looked at when we started our review of radicals. Is a perfect square is a number whose square root is an integer. And we can take a look and write down our first 12 perfect squares. The first one is 1, and then 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. We have 121 and 144. So those are the first 12 perfect squares. You can either memorize them or you have that list that you can generate. A square root is just the opposite or the inverse of that. Instead of taking a number and multiplying it by itself, we're actually dividing by itself. So if we take a look at this first part, it says find the square root of 36. Well, I'm looking for two numbers that are the same that multiply to equal 36, and that would be 6. The square root of 49 is 7. 144 would be 12. Now take a look. Next we have variables. So one thing we want to take a look at with variables, and we talked about this when we were working with exponents. If we have x squared, it's really x times x. So we have the same number times itself. We just don't know what that number is. So the square root of x squared would be x. When we're taking a look at the square root of 4x to the 4th, again, we can take the square root of 4. We know that one. It's 2. So that's outside the radical. But my x to the 4th is really x squared times x squared. It's that same number times itself. But we can break it down even further. It's x times x times x times x. So when we simplify this, we have two pairs of the same number being multiplied by itself. So we can take the square root of that. The square root of x squared, we already did that, is x. The square root of x squared again is x. So 2xx is what we have outside the radical. We want to rewrite that as 2x squared. We can also do estimating. We can find the number that's closest to the perfect square. So for example, 35 is almost the square root of 36. Well, we know the square root of 36 is 6. So this answer is approximately 6. It'll be a little less than that. 55, well, let's see. That's in between the square root of 64 and 49. Which one is it closest to? It's closest to the square root of 49. Therefore, the value of the square root of 55 is closest to 7. This next one, I think you can see that the square root of 99, it's almost the square root of 100. So it's closest and approximately 10. When we talk about perfect cubes, a perfect cube is a number whose cube root is an integer. So if we take a look at some of our first perfect cube roots, we'll go ahead up here. We've got them listed for you. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, and so on and so forth. It helps to have these memorized, or again, for you to be able to generate it yourself. A cube root is just the inverse of cubing a number. So here I've got my answers already up here. So let's see if we can figure out why this is. The cube root of 8. See how there's a cute little 3 on top of that radical? That's different than when there's a square root. Square root doesn't have a number. It's just kind of a plain radical sign. So be careful. Be on the lookout for those 3s now. And just like before, we can factor this. We can say 8, okay, that's 2 times 4. I'm using prime factorization here. And then 4 is 2 times 2. When it was a square root, we were looking for doubles or sets of 2 of a kind. Well, now it's a cube root. We're looking for sets of 3 of a kind. So once I find a set of 3 of a kind, they are represented outside the radical. And I don't have any leftover numbers that stay under the radical. The cube root of 27. Well, if I looked up at my cube roots, I know it's a perfect cube. I can go ahead and simplify that. If I'm not sure, I can say 3 times 9 and 3 times 3. Oh, here's my set of triplets. That's represented outside the radical. Again here, 5 times 25, 5 and 5. Here are my triplets. They get represented outside the radical. I like working with variables under the radical for cube roots too. This is just simply writing out, expanding out the multiplication. So underneath our little radical sign, we actually have 3 x's, x times x times x. Well, if I want the cube root of that, I look for triplets. I've got them. They're represented outside the radical. And I don't have any leftover x's for underneath the radical. Putting these two things together, the cube root of 8, if we're not sure, we expand it out, we factor it. We can see the cube root of 8 is 2. X to the 6th power, I'm going to expand that out as well. And I'm looking for sets of triplets. I have 2 of them. Now what is that going to look like outside the radical? Because I'm looking for cube roots, I'm just looking for the number of groups of 3 of a kind that I have. So I have 1 group, I have 2 groups. So that's going to be x to the 2nd power outside the radical. We can simplify radicals. Just like we did before, a radical expression is in simplest form if there are no perfect squares other than 1 in the radicand. There are no fractions in the radicand. No radicals appear in the denominator of a fraction. So we have to make sure none of these things occur. If they do occur, then we're just not done with our math problem yet. We talked about the product property of radicals. If I have the square root of AB, then I can break it up into the square root of A times the square root of B. Same thing if it's a cube root. Let's say I have a cube root of AB. That's equal to the cube root of A times the cube root of B. We also have the quotient property of radicals. If I have a quotient under the radical, I can break it into 2 radicals, one on the top of the fraction and one on the bottom. So we use these 2 properties as we simplify. Now I'm not going to take you through all of these examples because all of the ones that are just numbers we've done before. But now we're going to take a look at those with numbers and variables as well as cube roots. So we're going to take a look at example B. It says simplify 9x to the 3rd power. Well, I don't see anything here. It's just a square root. So I think about 9 and I think about, okay, what times what equals 9? That's the same. Or I use my factor tree. I have a set of doubles. That means 3 is outside of the radical. And I took a look at my x cubed. Well, that's x times x times x. I'm looking for doubles because it's a square root. Here I have it. I have 1 set of doubles there. That means I have 1 x on the outside. This is a single x. Does not have a pair to come out and dance with, so he's going to stay inside the house. So we have 3x square root of x. Let's take a look at letter B for the next one. This is a you try. You can pause your video and try it, and then come back and take a look. If we are to factor this, I can see the factoring 25, I get 5 times 5. The square root of that is just 5. Factoring x squared, I have x times x. Well, that's just x. Our answer to that is 5x. Let's take a look at simplifying with the fraction. So here I have it. We break it into two pieces. We're going to, again, look at b. I'm going to break this into the square root of 1 over the square root of y squared. The square root of 1 is 1. What's the square root of y squared? Well, if I need to, I can factor it. I have two y's. They come outside the radical and they're listed once, and that's my answer. So now let's take a look at using the product property rule and some variables. Remember that in the product property rule, we multiply like things. So if it's outside of the radical, we multiply it with other things outside the radical. If it's inside the radical, we multiply it with other things inside or underneath that radical sign. So if we were to take a look at 6 times 6 both in the radical, we'd end up with the square root of 36, which we can simplify to 6. Let's take a look at the next one. 3x is under the radical. I have a 4 outside the radical. Okay, so that 4 is going to stay outside the radical. And underneath the radical, I'm going to write 3x times this x. Well, I can't factor my 3, but I can look and see that, oh, I have double x's there. So that means they get represented outside the radical as 1x. And what I have left is just 3 under the radical. Let's take a look at this next one. I have a 3 outside the radical. It stays there. Under the radical, I now have 7. X times x, and y squared I'm going to just represent as 2y's. So I'm just expanding it out all in one step. I look under the radical to see if I have any double variables. I do. There are 2 of a kind for the x's. So outside the radical, they get written once. I also write 1y outside the radical. And my 7 stays inside the radical. You do have a note on your screen that when solving a square root using the radical symbol, we always take the positive roots. The last thing we took a look at before was rationalizing a denominator. We are going to take a look at both the numerical one and the one with the variable. So if we're rationalizing, we need to multiply by a funny fraction. And that funny fraction is equivalent to 1, but we use that radical from the denominator as both the numerator and denominator in our new fraction. Again, we multiply like things, so outside the radical with outside the radical, underneath the radical with underneath the radical. And then we want to take a look and see what we can simplify. 5 radical 7 will stay 5 radical 7, but the square root of 49 we can simplify to be 7. Last thing I'd check to see if 5 can be divided by 7, or if I can simplify that as they're both outside the radical, but in this case I cannot. Let's take a look at b. Again, we're going to create that funny fraction with the square root of 2x on the top and the bottom. This is called rationalizing the denominator. We multiply straight across the top. Notice that didn't become 8x under the radical because the 4 was outside the radical. And then here I'm going to get 4x squared. My top's going to stay just as is for now. And the bottom, we can take the square root of 4 to be 2. We can take the square root of x squared to be x. Again, the last thing I want to do is take a look at that fraction, the numerical fraction outside the radical, and see if we can reduce that. And in this case, we can. Our final answer should be 2 radical 2x over x. And one thing I can't do is cross out these 2 x's because one is in the radical, the other is not. We're going to pause here, and our second video is going to have some more examples of cube roots and square roots with variables.